Computer Science 190, lecture number 5, September the 1st. Okay, let's go. So I want you to work with Eclipse or use online compiler. If you have issues, then attend tutoring sessions. Please attend labs on Fridays. Highly recommend that. Quiz on Thursday, and we're usually going to have quizzes on Thursday, every Thursday. Will be very similar to what we had last time. However, this quiz this Thursday is going to cover the material which I'm going to talk about today and which I talked about on Thursday last week. Okay, and that's going to happen every week, right? So quiz. So quiz on Thursdays will be covering the material on which is given on Tuesday before that Thursday, and on Thursday a week ago. Okay. In general, we'll be having quizzes on Thursdays, homeworks due on Mondays. Email me if you have questions. Okay. That's not needed. Okay, cool. So let's start. Data types. I'll be using online compiler just to give you some examples, because it's easier for demonstration purposes. But again, you guys should definitely use Eclipse. Okay. So before I was talking about data type called integer, like int a is equal to 5, right? Okay. Now we also talked about that I can't really say a is equal to 5.5 because in this case a is an integer, right? And 5.5 is not an integer. That's why in order to avoid that, I would have to say double b is equal to 5.5, right? So that should already work. That should compile. Am I right? Perfect. Okay. Now sometimes what I can also do, I can call it a float. Float is very similar to double, but I have to convert it to. I have to use this in order to make it a float, right? Yeah. Okay. Anyway, today we'll be talking about a couple of data types which you guys need to know. Okay. So one of them is. So here we have a table, and those data types are called primitive data types. Okay. So there are primitive data types and there are complex data types. For the first part of this class, we'll definitely be talking only about primitive data types. So if you want to distinguish them, like if you're looking at data type and you want to understand if it is a primitive or non-primitive, just take a look at how it's spelled. So if it is if it starts with a lowercase letter like int, right? In that case, it's a primitive data type. If the data type is something like integer, like this, okay, so that's not a primitive anymore. That's more complex. So what kind of primitive data types we have? Here we can see integer, okay, int, right, integer. So the first column represents how we spell the data type in Java. Second column is what it actually physically means. Third data type is how much memory it occupies, okay? So please remember that a computer understands only zeros and ones, right? We measure memory in bytes, kilobytes, gigabytes, terabytes, okay? Oh, by the way, hold on. Let's talk about the quiz. By the way, yeah. Let's start with the quiz, sorry. Let's go over here. Content. Quiz number 1. Okay, cool. Let's talk about the quiz and the answers which you should have given. What does CPU stand for? Central Processing Unit, right? So that should be simple. Why do we need CPU? Those are pretty close. However, the last one is the only one which actually matches the slides exactly. The brains of the computer for where the most calculation take place, right? So process the data. It does not process any data. It makes sure all the operations are executed in order. No, it's not true. That's not why we need a CPU. It moves data from the hard drive to the flash. That's also not really why we need a CPU. So the brain of the computer where all the calculation take place, that's the most relevant answer. RAM stands for Random Access Memory. Select all examples of CPU. Examples, okay? So AMD is not an example of a CPU, it's a company, AMD. Central Processing Unit, of course, neither. It's not an example of a CPU. Intel Core 5, Intel Core 7, Intel Pentium 1. Those are examples of specific models of CPU. What are two types of memory we have? Main and auxiliary, main and secondary. Okay. types of memory. So RAM would be specific memory kind, but the type, main and auxiliary, and main and secondary. Mark of the programming languages, low level. Okay, Java is not a low level. Machine language. Okay, binary language. Binary language is not a language at all. It's a binary code. There is no language like that. Zeros and ones, pretty much the same thing. It's not a language either. Assembly language, it is a language. Java, C#, Python, those are all high level. Mark all high level programming languages. Java is one, C#, Python. Okay. What does a compiler do? Compiler translates high level source code into machine or binary code. Okay. Now this is the 9th question I was grading manually. Java application is a regular size program. Java applet is a smaller size. Java application is meant to be run on your computer. Java applet is meant to be sent somewhere else. Now, how many B in 1 TB, right? So how many bytes in 1 terabyte? That question was a bit tricky, a bit more difficult, but here's the right answer. So those, there were a couple of students who said it was like, they put 1 and 12 zeros. That's kind of correct, but that's not exactly correct. So that's why I put the word here exactly. You can use Windows calculator or anything else. So let's talk about this. How can we calculate how many bytes in 1 terabyte? Okay. So basically, I need to start with the bytes, okay, and then kind of like move that like in that scale. So what goes after 1 byte, right? We have 1 kilobyte. Okay. So let me draw this. Okay, so 1 byte, well, no, 1 kilobyte, that's 1024 bytes, right? Then 1 megabyte, that would be 1024 kilobytes. Then 1 gigabyte would be 1024 megabytes, and 1 terabyte would be 1024 gigabytes, and then petabyte and so on. Beta. Sorry. Okay. Now, in order to basically understand how many bytes in 1 terabyte, we just need to multiply all of them, right? So we need to multiply. We can basically say that 1 terabyte is equal to 1024 gigabytes. Okay. Now, what is 1024 gigabytes? 1024 gigabytes is 1024 times 1024 megabytes. Okay. What is now let's expand 1024 megabytes. What is 1024 megabytes? So it is 1024 times 1024 kilobytes. Okay. 1024 times 1024 times 1024. Okay. So now what is one? So it's 1024 times 1024 times 1024. Kilobytes. Right now, what is 1 kilobyte? It's 1024 bytes. Okay, and that's pretty much it. So if you multiply those 4 numbers together by each other, you'll get what I have in here, like this number. Okay. So that's the exact number of bytes in 1 terabyte. Hope it makes sense. Extra credit question. Okay, so extra credit is a section, of course, where I put more difficult questions, but it's extra credit at the same time. Okay, what is the output of the following code? Public class main, public static void main, string args. Okay, int a is equal to 7, int b is equal to 4, int c is equal to a over b, system that print out c. Okay. So what's going on here? We basically have 2 variables, a, b, and c, right? So variable a is equal to 7, variable b is equal to 4. Okay, so we have 2 integers. And after that, what are we doing here? We're trying to divide a over b. So we divide 7 by 4. Okay. And what's 7 divided by 4? So that's probably like 1.7, 1.8, I'm assuming. Where's my calculator? 7 over 4. 1.75, okay? 1.75. Yeah, 3/4. Perfect. Awesome. And that's probably what should be assigned to C, but the problem is that C is an integer. So we can't really have C is equal to 1.75 because C is an integer. So something should happen. And unfortunately, in such particular cases, Java does not throw an error and it doesn't show you any warning. It doesn't really complain about anything. What it does, it just takes the whole part, like 1, and just throws everything out, everything else. So even if you have 1.9999999, if you assign that to an integer variable, it's going to be just 1. Unfortunately, that's how it works. And I know it's stupid because, again, I wish Java would at least say something about that, because you're basically losing so much data. That's unacceptable, like in my opinion, but that's how it works. Okay, so that's tricky. That's not. That's why it's not 1.75. It's not 2, right? Which would make sense because it would kind of round it to the closest integer. 1.75 rounded up or rounded to the closest integer would be 2. That would also make much more sense. But unfortunately, that's not how it works. It's not 0, not hello world, of course. So that's like absolutely insane. So definitely don't choose that. Why? Because if hello world or this kind of hello world was printed out, what does it mean? That means in system.out.println, that should be something which would indicate hello world. And here we have C, right? And C is some numerical value for sure, so it's definitely not hello world, definitely not the answer. This would also maybe make sense, like the program won't compile, run, it will show an error, right? Unfortunately, that's not how it works. Definitely, if you guys want to, again, since it's everything open so far, right? You can just copy this code, paste that into Eclipse, and see how it works. Okay, so the right answer is 1. Although I know it doesn't sound logical. Anyway, so just keep in mind, and I will be repeating this example similar to that a couple of times. If you're dividing an integer by an integer, and then you assign if you're dividing something by something, and then you're assigning that to an integer, right? What Java is going to do, without telling you, without letting you know, it's going to take the whole part. After the decimal point, is going to throw that away, right? And then that whole part will become that integer. That's how it works. Okay, moving on. So int, right? Integer, 4 bytes. Okay, so 4 bytes, that means in memory, somewhere in that RAM, somewhere in those transistors, one integer basically takes how many transistors, right? So 1 byte is 8 bits, right? And we have 4 bytes. 4 times 8, 32 bits, right? So again, in memory, somewhere in RAM, one integer value, when you created one integer value somewhere in the memory, in the RAM, 4 bytes or 32 bits, 32 transistors become dedicated to that integer. Okay. Now the question is, what's the range? So how big is how big can it be? What is the span of the ranges? In other words, integer, right? So let's say 1 million, 1 billion, 1 trillion. Is that an integer? Technically, yes. Okay. Now, does that mean I can do something like this? Int a is equal to 1 and let's say 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So a will be equal to 1 billion. Is that possible to happen? The right answer is you need to take a look at how many transistors are there, right? So unfortunately for us, we have again 32 transistors, and 32 transistors. How much memory is that? How many values of different integers it can hold? And here in the last column we have the range of values. So over here, 4 bytes, we can see that this range of values, it goes from negative to billion to positive to billion. From negative to billion to positive to billion. Okay. So let's talk about that for a little bit. Well, first off, the answer to my question is yes. It's possible that an integer would hold 1 billion, okay? But if I was talking about 1 trillion, no, it wouldn't hold it, okay? Which is also like something you need to know. It's a hardware limitation, okay? So again, you may be thinking integer, okay? 1 trillion is an integer, so why can't I say like int a is equal to 3 more zeros? Technically, that should not work. Maybe in the online compiler, I don't know, is it gonna work? Technically, it shouldn't. Okay, perfect. Too large. Okay, awesome. Well, actually, that's probably the first time when the Java compiler told us what's wrong. yes, the integer is too large. Okay, although it is perfect, although it is an integer, 1 trillion is a legitimate integer. Okay, now let's talk a little bit why that happens. So what's the problem with that? Why can't we say int a is equal to like 1 trillion and I don't know, like huge amount of zeros? Why it shouldn't work? Just historically it was formed that way, that integer was assigned to 4 bytes, and it came from C and C, C++, C#, all of them, and yeah, almost all of the procedural programming languages, and Java is one of them. They all have integer being having only 4 bytes. Okay, so 4 bytes, right, or 32 zeros and ones, 32 bits. Okay, let's talk about that. So what is the lowest value you can have with 32 zeros and ones, right? That'll probably be 32 zeros. So if I have a bunch of zeros, then a bunch of zeros, that's it. Okay, so if I have 32 zeros, right, I'll have the lowest possible value of that number. Okay, now what would be the highest possible value? Okay, well, I guess the next value after that would be what? Would be zeros and then 1 at the end, right? The next value after that would be no. Well, okay. Okay, the next value after that would be like also a bunch of zeros, and then you want to say probably 2, right? But no, unfortunately, in that in binary code, we cannot have 2, because again, it's either zeros and ones. That's why it's interesting. It goes like 0, 0, 0, then 0, 0, 1, and then 0, 0, 0, 1, 0. 1, 0, because it cannot have 2 again. So there are only 2 states, either on or off, either 1 or 0, either yes or no. Only 2 states. Okay. Anyway, so, and what is the biggest value we can get with 32 bits? I'm sorry. What's the biggest value we can have with 32 bits? That will be, of course, all ones. Okay, all ones. Perfect. So let's talk about like how many values are there in between all zeros and between all ones. Okay. I don't want to talk about how it's like, I don't want to give you the entire mathematical derivation. Just remember the formula. Okay. So if you want to find out what's this range span of different values you can place into some amount of bytes or bits, here's the formula you need to have. You basically need to take 2. Okay, 2 is basically is because there are only 2 possible states, 0 or 1, right? And you need to raise it to the number of bits you have. Number of bits. Okay, 2 to the power of number of bits. In our case, how many bits do we have? We have 32. Okay, so 2 to the 32nd power would be, not sure if you know the math well, it'll be 4 billion, approximately 4 billion. Okay. So in other words, in 32 bits, we can at most place 4 billions of different values. Okay, 4 billions of different values. So what they might have done, people who developed Java and C, they might have created data type integer, right, to hold the values between 0 and 4 billions. Okay. That doesn't really work, because what about the negative values? In that case, we don't really have any negative values. We can't really have integer like negative 1, negative 2, negative 3. We can't really have that. So that's why what they decided to do is you have a span of 4 billion. They kind of shifted that to have a center of 0. Okay, so imagine that's a number line, right? Imagine that this is 0. Okay. So this, the range space will go from 0 up until here, right, which is 4 billion. That's 4 billion. Okay, so what they decided to do is to shift this rectangle to the left, okay, and they end up having basically something like this. You have 0 here, the origin, and then you shift that rectangle, you shift that span to the left, and now we have 0 in the middle, right? And then it will go from approximately negative 2 billion to approximately positive 2 billion. And that's how they ended up with that range. So here we have from negative 2 billion to positive 2 billion. Then another tricky question, which you can probably remember because I think it will appear on the quizzes a couple of times, is why it goes from negative 2 billion, blah, 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 a lot of numbers, and then 8, to positive 2 billions, blah, 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 a lot of digits, and then 7, not to 8. Okay? Why do you think it works that way? Why it's not symmetrical? And the answer is it's not symmetrical because there is 0 also, right? So in total, it's an even number, right? You have, but also if you take 0 into account, that's why you have that way. Okay, and for some reason they kind of shifted the balance like one number to the left versus to the right. Okay, make sense? Hope it does. Awesome, cool. Now let's talk about a bit smaller numbers. Okay, byte, 1 byte. 1 byte is, and that's how you spell it, right? So you would spell it this way, byte. Byte A is equal to 8, for example. Very rarely used, okay, so the memory used is 1 byte, so it's only 8 bits. Okay, that's why you can't really place in 8 bits like the 4 billions, right? You can't have that. So the range span will be how many? 2 to the 8th, right? Which is 256. 256 divided by 2, shifting to the left, you get from negative 128 to positive 127. Exactly for the same reason. So 256 total, shifted to the left, right? So 0 is in the middle, and then because of 0, it's from negative 1 to 8 to positive 1 to 7. Now short is considered to be short, that's why it's called short integer, right? It's only 2 bytes, which is 16 bits. It goes from negative 32,000 to positive 32,000. Okay, so 2 bytes. 2 bytes is how many bits? 16, right? So 2 to the 16th, what is that? That's 64,000. And if you divide it by 2, shift it to the left, do exactly the same stuff, which I described. You will go also from negative 32,768 to positive 32,767, right? Exactly the same thing. Integer, then long, right? So basically at some point people decided, hey, like I can't really hold like 4 billions into an integer. That doesn't make any sense, right? And that's why they created a long number. The size of it is 8 bytes. It can also hold only whole values, whole numbers, right? But the span is, since it is 8 bytes, not 4, 8, okay? The span is much bigger. It's, I don't know how to calculate it. How many zeros we have? So how many like trees of zeros? 1, 2, 3, 4. So it's thousands, millions, billions, trillions, and a couple of more, okay? So huge span, okay? Perfect. 8 bytes. By the way, question for those of you who are very, very hungry and to want to achieve a lot and to want to be ahead of the game. If I have 4 bytes, right, and if I can hold, so if within 4 bytes I can hold 4 billions of values, right? If I double that range, if I double from 4 bytes to 8 bytes, does that mean that my range also doubles? Yes or no? Floating point, okay? Basically, that means a number with a digit, with the decimal point in there, right? It's also 4 bytes, but now the way it's created, it's completely different. The formula, how you would create that value, it's not like from all zeros to all ones. No, they create like it's just crazy, insanely crazy formula how the number is being created. So like where you place the bits and what those bits mean. That's why that formula like really turned out to be working really well, and that's why you can have a value there from here to here. So check this out. It's like negative 45th power to positive 38th power. Okay, so it's crazy range. Double, right? It's basically the same thing as a float, but has twice as much memory, which means it's absolutely insane amount of values, like positive 308th power, negative 324th power. It's insane. Char or car sometimes, character. Okay, it's a single character. It only takes 2 bytes, all Unicode values. So 2 bytes. So basically, like, when you want to create not a number but a single character, like capital A, lowercase a, lowercase z, right? And you want to use that, for example, to print that out. So that's where it takes place. Character, only 2 bytes. And the boolean, we already talked about that. 1 bit, true or false, right? So basically, again, if you want to experiment with that, take any name from the left, let's say lawn, okay, and just like type that out, lawn, then create any name you want, my age, and then, I don't know, we'll just put a bunch of numbers there, a bunch of digits. No? Too large, okay, too many. Would that be enough? Perfect. Okay, so that's kind of the syntax. Again, the data type first, then name. You can come up with any name you want. The only thing is that you need to start with the character. You cannot start with a digit. I don't think you can create a variable which will be called, for example, my age. I don't think it's allowed. Okay, not allowed. Perfect. Then equal sign, and then whatever it's equal to. Moving on. Okay, perfect. Today we'll be talking about style and documentation. Okay, so basically you are getting into the stage where you'll be writing a lot of code, and sometimes when you show that to your friends, or when you want to kind of save this code, for, let's say for another class, right? You save it somewhere in your hard drive, and then half a year later or a year later, you want to come back and you want to understand what you wrote. Okay, so for that purpose, it's very important to format your code really well, in a very beautiful way, because it'll be easier for you to understand what you did half a year ago. It'll be easier for somebody else to understand what you've done. And also, when you apply for a job, when you get a job, people, your managers, your colleagues will be very impressed with your skill. It's considered to be super duper cool in the workplace when you format your code well, when your code looks like extremely beautiful. That's considered to be very cool, and definitely want to build that discipline in you guys from the very beginning. On the right, I prepared some memes for you, usually just to have fun. But on the left is basically what I have as a rule, right? So those rules need to be remembered. Take notes, definitely. Again, you're going to submit them by the end of the day, and you'll be tested on them also on Thursday. Okay, there'll be some questions in the quiz about them. Style and documentation, okay? Well-written programs are easier to debug, easier to maintain, and have fewer errors. So those normally are 3 things why we format the code. Okay, so easier to debug. What does that mean? That means there is a mistake, there is a bug, right? And you want to find that bug. It's much easier to find the bug when the code is formatted correctly, versus, imagine I had something like this. I don't know. Let's try to make it ugly. Let's try to make it ugly. Okay, like this. Okay, something like this. Okay, so when I'm looking at that, I have it's very difficult for me to understand what's going on, right? And that's why if there is an error, for example, it says like variable a, something is wrong with that, it's very difficult for me to understand where the mistake is. Especially if you place a lot of instructions on one line, right? And the Java tells me, hey, it's somewhere on the 17th line. It'll be very difficult to find where the problem is, because there is so much I placed on one line. Definitely not acceptable. Okay. Yeah. Anyway, writing program is like a lot of like writing an essay. When writing an essay, your message is more convincing when it's accompanied by proper grammar and punctuation. It is even more important when programming, since someone may be assigned to maintain and support your code for long periods of time. And here's kind of the practical rule, how it really works normally, okay? You will appreciate the importance of good style when it is your task to understand and maintain somebody else's code. Okay, so usually what happens, actually not to our students, but usually what I've seen a lot when I was teaching at other universities, people don't really care about how to write the code. when they have to maintain it. But once they start maintaining somebody else's code, they just they have no, because like they look at something, they have no idea what that means, and they start appreciating, and they start telling that person like, hey, can you please like write the code well such that I'll be able to understand it. That's the practical rule. Moving on. Variables. Okay, so what is a variable? Variables are short but meaningful name, so it's usually a noun that communicates with a casual observer what the variable represents rather than how it is used. Okay, so when you write in the variable, please begin with a lowercase letter and use camel case, mixed case, starting with lowercase. Okay, so if a variable called mass, then you just say mass. If a variable is hourly wage, okay, start with the lowercase letter, hourly wage, hourly, and then have a W capitalized. Is prime, start with lowercase I and then P capitalized. Moving on. Constants, use all capital letters and separate internal words with underscore. Okay, so for example, usually when I'm thinking about the constant, so what would be like a very good constant? Pi, right? The number pi. So in that case, I would say it's double pi. Okay, pi equals to 3.14. Pi. Okay, so not like this. If that was the case, that would be a normal variable, right? But if we have no intent, if we're not going to change the value of that variable, just do the same thing but capitalize that, like this pi. Boltzmann, max height. Okay, good examples. So again, if you have two words, just separate them by the underscore, by the line in the middle. Moving on, class names. Okay, so what is a class name? Class name is this, like main, right? So this word, this particular word. You know, it's like when you eclipse, you do the right click and then U and then class. Okay, so that's the name of the class. Okay, so how to format that word? Okay, so that should be a noun that communicates what the class represents. Okay, in our case, again, you can just name it like homework number 5, HW5, class practice, something like that. Begin with an uppercase letter and use camel case for internal words. For example, class complex, class charge, class phone number. Okay, so if you guys want to, you can say something like homework 5. Okay, HW5. You can do something like this, or you can say homework 5, like this. Moving on. So again, variable is a noun, right? Constant also a noun but capitalized. Class also a noun but starts with capital letter. Method. Okay, so method are usually the verbs. Okay, that communicates with what the method does. You need to begin with a lowercase letter and use camel case for internal words. Okay, so a method is an additional action, which you call it. So main is a method, right? And that's the only exception from this rule. Main is not a verb, it's a adjective, right? Well, I don't know, maybe in programming that will be considered to be a noun, but anyway, if you're creating your own method, and you'll be doing that very soon, you need to make it look like a verb. For example, add. Okay, so that's an example of a method which does nothing. Okay, but still, it's called add, right? So why is it called add? Because that's a perfect name, because it's a verb and it represents what it does. It probably adds, I don't know. I can also say add two numbers. Or I can say add two ints, which means add two integers. Moving on. Comments. Let's talk about the comments. Okay, so there are a couple of options here. There are a couple of types of comments. Okay, so one of them is called the line comment, which basically means that will be an end of line comment, which begins with two forward slashes, forward, not a backward, forward, and ends at the end of the line on which the forward slashes appear. Any text from double slash to the end of the line is ignored. Okay, so that would be the line comment. I don't know. So creating a new variable. Okay, but in this case it's a constant, right? So constant, something like this, creating a new constant. Block comment, what is that? What is that? It begins with / asterisk and ends with the same thing but in the opposite order, asterisk / and it tags between the delimiters, even if it has multiple lines, is ignored. Okay, so block comment is basically used when you want to have a comment which includes multiple lines. Okay, so for example, what if I can say like here, hello, no, hello, okay, my name is, and then here I want to say like Professor Ruben. Okay, so that's a way of doing that, right? However, it's probably not the best way because I need to like type so many characters. Although again, it's completely up to you. But if there is some piece of information which you want to put in a comment, it's much better to do it the following way. So let me delete this. Okay, so now you see it became white. Why? Because I deleted the / and now Java doesn't really think it's a comment anymore. It actually thinks it's a real code. Of course, that has nothing in common with the real code, right? It's not real code. And now if I run it, of course, it's going to show me an error, right? It doesn't know what that means. So again, that's how coloring helps you. Okay, but now if I want to create a comment out of it, so I need to go before the comment. I need to put / asterisk, okay, and then here after the comment */. So now you see again it became that brownish grayish color, okay, and now it thinks again that it is actually it's a comment. Okay, so now it works. Perfect. Hope it helps. Line and block comments. So how to create them? So block comments, or bold comments. Okay. So bold comment would be like a subsection or subcategory of a block comment. Okay, and it's a special case of it and designed to draw attention. Okay. So if I reload this page, that thing at the very top, right? You see this. So that would be considered to be a bold comment, right? So basically, it's a huge amount. It's a section, right? Like actual section comprised of how many? 7 lines, right? And it's designed to draw your attention. So you would place a lot of information here, ideally. That would be a block comment. Bold comment. Sorry. Okay. Now here we have a bold comment, which you need to copy and use it for every single homework. You don't have to use it for practice, you don't have to use it for labs, but for every single homework, you definitely need to use them. Okay, and for every projects which you're working on in your school career, you definitely need to use this. We actually talked to all of the professors in our department, and we all agreed that we'll be using this convention. Okay, these rules. So let's take a look. That's a bold comment, right? So you can see it's a / asterisk, and then here we have also asterisk /. So everything in between here and here will be ignored by the compiler. It's considered to be a comment. And then over here, I basically have author, right? Colon, and then your name, written, colon, then your date, okay? And just please notice how it's indented, right? So they're vertically aligned. You see this? And you see it also over here, right? It's kind of like in the same column. Written, the date when it was written, last updated, the date when it was updated. Most likely when you're doing homework, it will be exactly the same dates. You write, and that's the last time you update the code, most likely, right? But still do that, Compilation, Java C hello world.java. So in your case, you need to say compilation colon, also align it, right? Java C, and then provide the name of the file of your .java file. For example, homework5.java. Okay. Execution Java, and basically do the same thing but without .java. Okay. And then here you need to, in the free form, like verbally, but just try to stay formal, professional, explain what the program does. Okay, so for example, if I asked you to print out Java like in that beautiful way, right? Then you would say that this program prints out Java in a very nice and fun way, entertaining way, something like this. Okay, so basically, what is the purpose? And then here, percent sign. Okay, so those of you who are advanced with computers, you probably can guess what that means. Percent sign means terminal. Okay, so again, usually by default, especially back in the day, people didn't use Eclipse. They didn't have Eclipse. So what they were doing, they would open up terminal, right? So terminal. Okay. Not sure if you can see that, but basically, and you have that in, like on every machine, right? So back in the day when computers were not that advanced, the only thing they would have that would be a terminal, right? And here they would type the code. So well, no. They would create a text document. They would put all the code there, right? Then they would find the document, and then they would just say Java C, right? Like hello world. .java, okay. Found, right? So it's going to compile the code. Then they're going to execute it. Hello world.java, right? So that in this particular line, that means how to explain that? It's basically sample output. Okay, sample run. Yeah, that's what it's called technically. Sample run. Okay, so you're basically saying that here's my code. If you run this code using these commands, Java C hello world Java and execution Java hello world, approximately that's what you're going to see. Okay, so percent sign means you locate it in the terminal, right? And that's what you would type here. So you basically type in the terminal exactly what you said here, right? So Java hello world. So Java hello world. Okay, and then when you push enter, right, you're gonna have some output. For example, hello world, right? And that's what you need to type here as well. Okay, so in other words, you're basically telling to the person who'll be using your code, you're basically saying, hey, if you compile my code, if you run it, right, if you run it, one of the possible outputs of my code is this. Okay, so that's called sample run, and this percent sign means that like it's happening in the terminal. That's kind of the technological term. Whew, hope it makes sense. Moving on. Comments. Okay. So check out what happens here. Private double Rx Ry, private double Q. Okay. So and here we have position. Okay. Comment every important variable, including all instance variables with / comment, and align the comments vertically. So although this line over here is longer than this guy, and it was possible to start a comment a bit to the left, right? If you just do it this way, it's much easier to read, and it's considered to be much more beautiful, much more professional. For example, if I create variable int a is equal to 5, then let's say a couple of more variables, then int something like this is equal to 10, right? Well, I don't need that many. Okay, so what I can do, I can create a comment here, comment, right? And then since the first two lines were shorter, I can also probably create them here, right? And that technically they'll be correct. However, it's not as beautiful as this. It's not as beautiful as finding amount of tabs which is needed to make them all aligned vertically like this. And yeah, and that's how you would comment all the lines. That's considered to be much more professional. Commenting. Moving on. What else? So so first off, I want you to comment each variable which you're creating, like int a, int my age, double my height, all of that. So each one of them should be in a separate line and having a comment, like creating this, creating that. This variable will be used to do this. So comment is basically is a phrase, right, which you would use to explain your friend how this code works. Okay, so it's more or less formal / informal language to explain somebody like your friend why you're writing this and how it will be used. Again, comment every variable and then comment every method, okay, with the description of what it does. Include what it takes as an input, what it returns as an output, and any side effects, okay. So for example, we have a method called shuffle, again a verb, right, shuffle. What does it do? It rearranges the elements in the array A in random order using Nath shuffling algorithm, and throws an exception. Okay, yeah. So every method. The only exception would be main, because it's standard. So if you're not writing new methods, which we are not doing yet, do not add any comments. Once we start writing methods, you'll need to do this. Moving on, white spaces. Okay, so programmers use white spaces in order to make things easier to read. Don't put more than one statement on a line. Use blank lines to separate your code. If you want to, you can use this. So you see, a times x plus b. Okay, and now they didn't put space in between a and times and x, but they put a space between like surrounding the plus. Why? Because multiplication takes place first and then addition takes place second. So that's kind of why it's easier to read. White spacing, okay. So include white spacing between keywords while for if, okay, and opening parentheses. Put a space after each statement for loop. Okay, we'll be talking about the loops very soon. Okay, so if you consider this statement and this statement, this on the left, that's much more beautiful, much easier to read. Okay, so do this. Put a space after each comma in an argument list, and put a space after each comment delimiter. Okay, so this is not as good as this. So please stick to this convention. Space / and then space. Okay, versus this. Okay, now same thing if you create a lot of variables. Int n is equal to 5, int trials is equal to something else. So just like make them equal, vertically aligned. Again, a couple of more rules. Avoid lines longer than 80 characters. Okay, not going to happen anytime soon, but if it does, please split them into 2 lines. Do not put more than one statement on the line. Definitely use tabbing, right? You see, like over here, it's a tab, and this is a tab. Or if you use spaces, usually like use 3 or 4 spaces instead of 1 tab. Okay, now a couple of things at the end. Okay, so go ahead and read it. Read the slides. I don't want to stop too much on it. But here's what you need to know. Okay, so these curly braces, they represent blocks. Okay, so if you have an opening curly brace, then you're also going to have the closed curly brace. Okay, so class block, for example. So class goes between from here up until here. Okay. Now the main method goes between here and up until here. Okay, so if you omit one of those braces, it's not gonna work. Java will be very confused. So you definitely need to keep an eye on that. Okay. What else? Okay. Yeah. So characters. So special characters in Java. What are they? Take a look at these braces. Let's take a look at these special characters. So braces, what do they mean? They usually denote a block to enclose statements. Okay. Now parentheses, what do they mean? They usually mean method. Okay. So check this out. This brace is used to open this block, and here where it's closed, right? This brace is matched with this brace. That's how you open a new method, main method, and that's how you close it. But the parameters of that method are usually inside the parentheses. the square brackets, right? What are they? They denote an array. Array is basically a set of variables put in under one block. Okay, we'll be talking about that later. So you're not going to use that for the next couple of lectures, couple of weeks. Double slash denote comment. Okay, then quotes. They usually have denote a string. Okay, so it's possible to create a variable of the type not integer, not double, but a string, which is basically a regular string, right? So you would type string with a capital case, okay? String b is equal to hello Java, okay? Notice that string starts with a capital case letter, which means it's not trivial, right? Data type, it's a class, it's more complex. Okay, string b is equal to hello Java, and then everything between the quotes is a string, similar to this. Okay, it is a string, and it's usually colored in green by your IDE, by Eclipse. Eclipse usually colors that in green. And then semicolon, what does that mean? That means we finished the line. Okay, so that means that's the end of the line. Semicolon. String b hello world, semicolon. That means that's it for this line. Okay, so please read these comments. Like have a lot of text here. That's I already described all of that, but please go ahead and read it just to make sure you know that. And yes, and as a test and exercise, highly recommend doing this. It's a very interesting thing to do. So 3.5 times 4 over 2 minus 2.5. What do you think that's going to be? Okay, is that going to match like your expectations? Yes or no? Okay, that's it for today, guys. I'll see you on Thursday. Please prepare for the quiz. Please submit the notes before the end of the day. Bye bye.